Hi again. In this session, we'll complete the introduction to reserve. As I mentioned in the earlier session, that the benefit reserve is quite complex topic, that there are lots of formulas and lots of approaches that how you can use to calculate the reserve. But as I mentioned, the reserve, we will take it light because this is we cannot cover everything in this term. So I think for 12 weeks term, I think this should be sufficient. So we'll continue, we'll wrap it up today, the reserve. So the point that we will discuss today is simply what we've done in the first session, but instead of the continuous case, we'll do the discrete case. So we'll only use a prospective method. So simply we have a life age X, policy was issued here. Now we are not at the time X. Now the policy issued here, and P it's discrete, so P was also issued, was determined here using the equivalence method, which sets L equals 0. Now we move forward. We are now here at X plus K. The question we wanted to see, what is the level of reserve? What reserve to keep? As I mentioned, there are two methods. One is you look backward and and accumulate the premiums collected and accumulate the benefit paid at this moment. But what we will do here, as I mentioned, we'll focus on prospective. So we'll look forward and bring discount back the benefit and discount back the premiums. But the premium is determined here, right? You need to keep this in our mind. The premium that was issued. So the premium here, we get them back. And the expected value of L at this moment, KL in the discrete case, is not equal to 0. Only at the beginning it's equal to 0. So except if it's, like what we mentioned, certain cases it can be, but in general it will not. So we are looking for this one, and we give it, for the discrete case, we give it this notation, VK, right? VK, and then simply we keep it at X here. VK for a life that is age X, right? So VKX. So we don't have just the X to say that the insurance was issued for a person at age X and we are at year K. So this is the continuous case. There is no bar, there is nothing here, right? So, and this is what we want to determine, which is the expected value of this one. What is it, right? So we we can use the same logic what we did for this creation KV. The K at time X plus K, we look at the V for the reserve, and we can look at what is the actuarial now for the future benefits now. From here for the future benefits, so we don't care about the past. So what are the actuarial present value of the unit of insurance? So for the future X plus K. And what is the actuarial present value for premiums collected, and the premiums was determined already at time X, but now this discrete case, so we need to see the annuity and X plus K. It's very important, right? This one is very, very important to memorize. But it's logical. I really don't memorize formulas. It's logical for me. And if you want the variance of KL, so this is the expected value of KL, this one, and now we need to calculate the variance. The variance for it, simply the same logic in the continuous case. So you take the premium, but again the premium that is determined at age X, and now discrete case you divided by D, not lambda, because it's the discrete case. Right, it's very important to keep this in mind. Raised to 2. Now the second moment, 2ax plus k discrete minus ax to 2. Those are very important formulas that you need to remember, right? Let's take one example. Now we bring everything together. One little question like what you would see now, you would have to bring everything So little question now, it tells us to use the life table to calculate 10V70. And that's why all exams are cumulative. It's simply because you cannot calculate this one without knowing all what we learned so far. Right? As always, it's very important to write what you know. 10, and there is no bar here. So this is everything is discrete here. So it's easy. So we start with Ax plus k, 70 plus 10 is 80. Subtract from the premium that was determined at time 70 at the time of issuance. So we take, we see what is expected payout. We subtract from it what is the expected premiums collected. Right. So we need everything here. Let's take one by one. So let's bring in the life table. So I always like to let's bring it. So I always like to show it to you. I mean, so you double check with me. So we're gonna get from age 80, so 1 to the second one. Let's take one by one. So let's look at, we need A80. It's easier for me, as I mentioned, I keep it here also. It's easier for me to look at it. So 8, but for us, let's see together. We look at 80. Let me make sure, 59293. For 80 is 0.59293. And now what else we need? Let's take this one now. A80. Same, it's next to it actually. You don't need to go far. This one. 85484, which is the one next to it. It's easy to copy the wrong number here, so you need to be careful. 8.5484. What else we need to calculate here? So let's see, we got this one. Now the last one is P for premium. Again, this is not the small p for probability. You need to be careful here. For premium 70 is A70 divided by A70. Now we need to start over again. So we need to find A70 and A70. So now we need to go 10 years earlier. So if we go 10 years earlier here, so we have this one is to be well, I think it's easier for A70 is 0.4281 and this one is 12.0083. Right? Now we can write it again, just also double check it, 0.4281 divided by 12. I need my calculator here to calculate this one. 0.4281 divided by 12.0081. I got the premium to be 03565. keep it in your calculator. The answer, keep it in your calculator so you can block it in when you need. So now we got all pieces of what we wanted. So now we have all pieces. So you bring in this 0.59239. Oops, I mixed 293 minus, well, it's long number to write here, multiplied by this here. Let's see what I get. So it's good to keep this number. So this one multiplied by the 80, 8.5484, and now we need to get 59293, subtract from it this number, and you can double check what I got here is, I also already calculated it. Yeah, it's what I got here, 28817. Okay. Yeah, so it's really not very difficult, but let's take another one on the variance, right? Now, the second one we are asked use the variance of what we did here, the same one. Let's do the same one. We calculated the expected value for this example. Let's call this one A. Now we need B is variance. Let's call this one B. Question B, variance of 10L for the loss model, 10L70. Again, always write the formula, what you wanted to do. The formula is, as you remember, is 1, the premium issued to 70, divided now this discrete case, D, raised to 2, now 2A 80 minus A 80 to 2. It's good. We have the P70 already, I think. We calculated it. D is I over 1 plus I. So if you do this variance of 10L70, which will be, if you take this one, what the calculation divided by D, 1 raise it to 2, I got the 3.058, and this 80 we already got it here, right? The 59, and then you need this 280, and this one here, you go for 80, which is 3184. So we multiply it by 0.38134. You subtract from it, I already 59293 square. This is the variance. I mean, it's just the variance, and it's not important really the number now. It's just like you can double check it, but the method is what's important. Yeah. So it's straightforward. There is nothing difficult about it. Now let's take a more, like we talk V. Let's recall what we've done. In the continuous case, what we did, we look at V bar AX, right? And we said D. So this one, V, it says the premium is continuous, and A bar is the benefit is paid at that time of death. Then we did VK, we use K and X. So this one, we said it is now everything is discrete. Benefit is paid at the end of the year of death, and the premium is paid at the beginning of the year. Now, what if you would see a situation that is a little bit different? Now you have T, V, A, X, this mix and mixing things, you know, so you can mix anyone you wanted. Now the V, there is no bar in the V. There is here, so this one here, it will be AX plus T, right? You can write your own formula here. It's not, now you subtract from it. Remember what we did in the past. What we did here, we subtract from it the continuous if there was a bar, but here we don't have a bar. So here we have A and the premium also here is discrete. The premium always match the annuity, right? But the premium is calculated with the time X, right? Time X. But because let me put it here just separately. Even that we don't have bar over the P because it paid discrete at the beginning of the year, but we still need to say that the benefit when we calculate this premium was the benefit is to be paid at moment of death. But this is discrete. It has the P discrete and this discrete, right? So you can mix and choose, right? You can mix it and choose between them, right? So let's take another example here, for instance. So we need to use life table to compute 10 V A70, right? This is mixing things here. But we cannot calculate continuous because the life table is discrete. So we need to have the question will tell us assuming uniform distribution of death, UDD. So now we can do it, right? So again, always when you have question like this, write what you have. Now we look at the V. V is discrete, but the benefit is continuous. So we have A80, the prospective. Now P for age 70, and the P is discrete. There is no bar here. But because the P is discrete, then we need to use annuity as well with it. But the annuity, we're looking at the future premium premium collection. So this will be 80, right? Once you do that, you all set. Now you take, you know, let's see what we have. But A80, we don't have it. We don't have it in the table. But now here UDD, using UDD, this can be I delta A80. Right? And delta, so it's 0.5% because the life table we have at 5%, ln 105, and A80 we already found what's A80 earlier. If you go back to your note 59293, then this one will give us A80 to be already just a little bit different because of this factor 0.60763. See, it's bigger than the discrete. The discrete because you have to wait until the end of the year to collect the benefit, but this one you get it right away, so it's actually bigger because it's closer to the time of evaluation. So now we got this one. Now this one is already given because you can find it right away in the table, which you already find it before. Now the P A 70, nothing difficult here, right? It's simply P is discrete, so we know this is 70 here and this is continuous. Now this one you can write it if now using UDD here, then this can be I over delta A70 multiplied by A70. Now this one will be again 0.5 over ln 105 multiply. Actually this one you would see it's P70, right? Which we already computed, right? We already computed this P70, you already computed it. So everything here, if you do the what we calculate or you plug in what you have, you will get 03654. Now you got everything here. You got everything. Now you plug in everything you have here. Then if you plug in your numbers here, then you would get this one to be, well, let's plug it in here in different color. So let's include, so remember A80, we said it's point, the one we computed, because we have to multiply it by I over lambda, is 0.60763 minus our one also we multiply by I over delta, 0.364. Right? And then with A8, this one, if you add it up, it will be 0.2952. It should be a little bit bigger than the previous one, because again, like the benefit is closer to time of death. Right, so I think with this one we all set, I think. Yeah, just double check. Yeah, a little bit bigger than that one. All right, so yeah, maybe I'll take one, just the other formulas that can be useful. Many times you know, similar to the continuous, we'll look at other formulas here. For reserve, this is, remember, prospective reserve, prospective. The first one, for the discrete case, we looked at the one we use it for calculation, right? We used, like, to calculate kvx, we said we use this one, right? Ax plus k minus p, but at time of x, multiplied by Ax plus k. This is one we most of the times we use, but actually the other ones sometimes are much easier for certain situation. Now imagine if you factor out the Ax plus k, and you can verify it. It's easily, you can verify it, you know, play with it. You will see, you will arrive to this one. Now you will have two premiums. One is at time x, one at x plus k. Which one is bigger? The one is bigger, because we don't want to get the reserve negative. The one is bigger should be first, right? The one is bigger, I mean, you'd think that if somebody is age 80, will have to pay a premium for life insurance. It will be the premium much higher than an age 30. So this one will be the x plus k, subtract the x. The difference between these premiums, we take annuity of those differential of premiums. That's what gives us the k. Another one now, imagine if you take the Vx, imagine if you now take the Ax plus k, the bigger one. Now 1 minus, we need to have the two premiums here. Which one goes, again, the bigger one will go down there. Remember, the one is for 80. Right here, right? And this is smaller, because the younger person, the premium for younger person is less. Now another formula here, kvx, you can use anyone depending on the information given to you in the question. Now you can write it also, this one, Ax plus k minus the benefit for issued for A plus k, subtract from it the x. Now 1 over minus Ax, right? That another way. The last one, which is also easy in certain circumstances, this one is, again, now you will have two annuities. One is bigger than the other. Now life annuity, if like pension, if somebody age 90, the pension for the somebody age 90 is smaller than the pension of somebody 30, right? Because from 30 you until life expectancy in the 90s, it's a lot of money, but 90 it means that you have a couple of years. So the smaller one will be X plus K for the annuity, and here X, right? So any of these formulas you can use. Any of these formulas you can use to help you. It depends on the context of the question. Last time I gave you a question that we said in the uniform it's better to use this one. Now let's take another one that we'd have to use different one. Let's take this example. This example, we are given only A65 and A60. Let's make the numbers easy. One is 10, one again, like the 60 will should be sorry, let's make it, to balance it, maybe make it 50 and 60. So the 50, the younger person will be higher, the annuity. Let's make this one 8, right? And we are asked to find 10 V50. Now you look at those formulas, you use the, you can use any one of them, but you need to manipulate, and you can use like this one to derive the A capital. But then if you remember this one, now last time we used this one, now we're going to use this one. If you remember this one, it's easy. It's 1 minus the smaller one, which is A60, the older person, life annuity, over A50. So 1 minus 8 over 10. So the reserve is 20 cents for the $1 of insurance. Again, if you know this formula, it took me like 30 seconds this to calculate it. If you don't and you use the only one formula, it will you will arrive eventually at the same one, but it will take you a lot of time. You will arrive eventually, but it will take you a lot of time. So with this one we finished our course. So yeah, congratulations. I'm happy that you survived. It's lots of notations, but again, like not much here. What we covered, it's actually the capital A for benefit at time of death. Then we looked at the small a for annuity, and then the premium is the capital A over the small a, and then we looked at the reserve. It's really not much, but too many notations. If you try to learn them mechanically, memorizing formulas and you plug in numbers, very difficult. But if you try always to make sense of the formula, you always remember it, and it will come handy to you. All right, folks. Yeah, great. Thank you very much, fellows, for being with me.